And whenever you use the primary index in the where clause of the retrieval queries, you will get a 1 amp operation. And how do we choose a primary index? The column in the table which gives you almost even distribution, and the column which is being used more in the retrieval queries, maybe in the joins, maybe in the reports, maybe in the further SQLs which does some transformations. You will see the usage patterns of the columns in the table. If any column is being used more, and if that column gives you the unique distribution, that column is selected as your primary index. But it is not possible always in real time, isn't it? A single column which gives the distribution and which is being used more may not happen always. Right? So at the time, which column we select as a primary index will give priority to the distribution. Okay. So the distribution column which is giving almost even distribution, we select that column as a primary index. And to optimize the queries which are using the non-index column in the where clause, we will go for a secondary index to provide the secondary path of accessing the data. Okay, so secondary index gives you a secondary access path to the data, or alternate path to access the data. And whenever you use this secondary index in the where clause of the retrieval queries, it would result you in a 2 amp operation, or maybe multi-amp operation, or up to an all amp operation. It could happen at any level. It may be 2 amp level or an up to all amp level also. We'll see how the secondary index is used to get 2 amp or up to all amp operations. What happens when you create, we'll see that, but just for a knowledge purpose right now, second index gives you a alternate path of accessing the data in the table, and it results in either 2 amps up to multi-amps and all amps also. And when you don't have a secondary index, what happens? It always does a full table scan. What does it mean? For example, I have the employee table. Employee number is my primary index. If I use employee number in my where clause, I will get a 1 amp operation. If I don't use, then what happens? The parsing engine will instruct all the amps to work on their portion of the data for the employee table and retrieve the data. So all amps will work on their portion of the data in the amps and get the data back, and message passing will match the data sets and give the result set back to the users through PE. Right? So what happens if you don't use the primary index? It does a full table scan. That means all amps are involved in the access. Okay. If I give select star from employee where department number equal to 10, then yes, then again it is all amp operation, because you are not using the primary index in the where clause. Right? You are using a non-index column in the where clause, so it is resulting in all amp operation. So is there any way that you can optimize that query and to get an alternative path of access based on the department number? Because in the employee table, employee number is the primary index, but we are not able to use it in the where clause queries. I am using a non-index columns, a non-index column department number in the where clause, where it is causing an all amp operation always whenever I submit this query. So is there any way that I can optimize this so that it won't go an all amp operation, but it will go less number of amps operation than an all amp operation? Yes, there is a solution, that is the secondary index, where it will give you a 2 amp or an all amp up to an all amp operation. Okay, we'll see the characteristics of secondary index, and then we'll see how to create it and what happens when you create it. A secondary index provides an alternative path to the rows of the table. Yes, and it is used to impose uniqueness also on any of the columns. Okay, the secondary use of the secondary index is to impose uniqueness on any of the column, because secondary index also again can be unique or non-unique. Just similar as the primary index, you can create a non-unique secondary index or a unique secondary index. So whenever you create a unique secondary index, it won't allow the duplicate values on that particular column. So you can use this unique secondary index to impose uniqueness of any of the columns what you want to impose on. And a table can have 0 secondary indexes and up to 32 secondary indexes maximum. And each index can have up to 64 columns as a combination to create a composite secondary index. Okay. So please have an attention here. You can have up to 32 secondary indexes, the number of secondary indexes, and each index can have up to 64 columns as a combination to create composite secondary indexes. Okay. And the secondary index does not affect the table distribution, because the table distribution is always the primary index. No other index would impact the data distribution which is done as per the primary index. So secondary index also doesn't impact the data distribution which is guided through the primary index. It is another index, but it won't impact the data distribution of the primary index. It adds a overhead both in terms of disk space and maintenance. We'll see why it is. May be added or dropped dynamically as needed. When we can create a primary index? At the time of table creation only. Right? At the time of table creation, even you specify or not, it will take a automatic primary index. Okay? In case of a no primary index, it is a separate case, but if you don't specify anything, even the no primary index keyword also, then it will consider the first unique column as a unique primary index, otherwise the first column as the non-unique primary index. Okay, so the primary index is determined at the time of table creation only, but here the secondary index can be created at the time of table creation or after the table creation, and it can be dropped at any time. Okay, so it has a flexibility. Whenever you want to add, you can add the secondary index. Whenever you want to delete or drop the secondary index, you can drop it. And they are chosen to improve the table performance. Right? So instead of going for all amp operation, if you want to make it optimized to get a less number of amps operation, then you can choose it. So the secondary index purpose is to improve the table performance by accessing the alternative path. It can be unique or non-unique. We already discussed. Okay, so as similar as the primary index, it also can be unique or a non-unique secondary index, and it can have a null value, and it can be updatable at any time. Similar as primary index. Okay, primary index also can be null and it can be updatable. Similarly, second index also can be null and it can be updatable. Okay. How do we create a secondary index? See, a secondary index may be defined at the table creation. That means at the create table syntax, you can add the secondary index also, or after the table creation, you can create index with the syntax create index. Okay. While creating the index, see, this is the syntax. If you want to create a unique secondary index, you just use the keyword unique also along with the index. Here if you observe, the secondary is not mentioned here. You see, the secondary is default. For primary, the primary keyword is mandatory. You have to mention primary to create a primary index at the time of table creation. Okay, if you don't give any keyword that is primary or secondary, then it is default secondary index. Okay, so what index we are creating here? Unique secondary index. Okay, with the create structure, create unique index. On which column you want to have the secondary index, on what table you want to create this secondary index. Okay, this is the syntax. And in case if you want to create a non-unique secondary index, NUSI, then you just mention the keyword index. Secondary is default, Non-unique is default. Okay, so you no need to mention anything, just mention index. If you want to create a unique, then you have to mention a unique keyword, but if it is a non-unique, then nothing is required. Index means in Teradata by default non-unique secondary index. If you want to create any other index, you have to mention those keywords, but if you don't mention anything, you just wanted to create an index, it is default is non-unique secondary index. Create index, that means non-unique secondary index, on the last name column of the employee table. And whenever you use this unique secondary index in the where clause of the column with an equality condition, it causes a 2AMP operation. Always. Whenever you use this unique secondary index column in the where clause of the retrieval queries, it always causes a 2AMP operation. And whenever you use a non-unique secondary index in the where clause, it may be a multi-amp operation or up to an all-amp operation also based on the degree of duplication. We'll see that. And when you create an index with this structure, with the syntax, create unique index or create index, whenever you mention the index to be created for the table, what happens internally? A subtable is created. An internal subtable is being created. Let's see how a subtable is created and what is the purpose of it. Here see, we have to understand the subtable and how it is being used for 2AMP operation. Let's consider an example here. So here I am considering a table with 3 columns: customer number, customer name and phone number. You're able to see here customer number, customer name and phone number. I have 3 columns in the table, and when I inserted this rows, it has taken the phone number as the non-unique primary index, and all the rows of this particular customer table are distributed across all the amps based on my non-unique primary index phone number. Okay, so the table with these 3 columns is distributed based on the phone number. This is all. Each amp got certain number of rows, and my table is distributed across all the 4 available amps, and along with it the row IDs are also stored. What is the row ID? Row ID is the combination of the hash value plus uniqueness ID. How much size it is? As the hash value is of 32-bit and uniqueness ID is also of 32-bit, the row ID is of 64-bit. And on each amp, how the rows are sorted based on the row ID, right? So this is what my customer table distribution is. The customer table is distributed based on the phone number, which is the non-unique primary index, and all the rows within each amp are sorted based on the row ID. Okay, now I have observed the customer ID is being used more in the retrieval queries. So I wanted to create a customer number as my unique secondary index, because the columns are also having unique values. So I wanted to create a unique secondary index on the customer column. So I have used this syntax. Create unique index on the customer table. The cust is the column name, on the customer is the table name. Okay. When I create this unique secondary index on the customer column of the customer table, what happens? A secondary index subtable is created. See here, this is the subtable. What columns this subtable contains? The row ID of the secondary index column values, and the second column is the secondary index value itself, and the third column is the row ID of the corresponding base tables row. Okay, the subtable contains 3 columns. The first column is the row ID of the secondary index values, because when you create a second index, it is also given to the hash algorithm, and these values are also hashed, and when it hashed, it will get its corresponding row IDs, right? So those row IDs are stored as the first column, and the second column is the customer number itself. Whatever the secondary index, the secondary index values are stored as the second column of the subtable. And then the third column is the corresponding base table rows row ID. For example, if you consider this, customer ID is 56, so where the 56 customer ID row is stored? Here. And what is the primary index of this? The phone number. And what is the row ID based on this primary index? This is 778,7. That is the row ID. See, the corresponding base tables row ID is stored here as the third column. And what is this? This is the secondary index values row ID. This is the secondary index value itself. So these are the 3 columns comprising the secondary index subtable. So whenever you create the secondary index, what happens? A subtable is created with 3 columns, and as it is also a table, this also distributed across all the available amps. Based on what? Based on the secondary index row IDs. That is this row ID. Okay, based on this row ID, the subtable is also distributed across all the amps, and they are sorted based on the row ID of the secondary index hash IDs, row IDs. Okay, so I created the unique second index by seeing the usage patterns, and it has created a subtable internally. You are not going to create any table. You just give the syntax. Internally, Teradata will take care of creation of the subtables based on the second index what you choose. Okay, so now I started using my second index value. How do I use? In my select query. Select star from customer where cust equal to 56. That is the customer. The customer where cust equal to 56. So I'm using my secondary index value here. So when I created the second index, it was hashed and it has created row ID and it has distributed across all the amps. And when you are using this unique second index in the where class, the parsing engine knows there exists a secondary index based on this column, and it gives this value as input to the hash algorithm again at the time of retrieval. See here. So hash algorithm, you consider the unique second index value whatever you used, and this hash algorithm generates the row hash for this unique second index value 56. So 602. So by seeing this hash value, parsing engine can determine in which amp this particular row is being stored, because we know the hash map. Okay, we know how the message passing layer will find out in which amp this row exists. So by seeing this row hash value of the secondary index, we will just jump onto that particular amp in this particular position, and it will retrieve the subtables row first. Yeah, this is the subtable row which is corresponding to the customer value 56. Okay. Based on the hash values generated, it has identified this particular amp holds the subtable row, and from this it will identify where exactly the base table row is being stored, because as the third column we have the base tables row ID. So by seeing the row ID, hash algorithm automatically can decode in which amp and which position this particular row exists. So it will analyze those hash value and uniqueness value, and it will identify in which amp this row is being stored. You can jump to that particular amp at this particular position and can pick up the data. So how many amps are accessed when I use my unique second index here in the where class? The first amp is to identify the subtable row, and a second amp operation is to identify the corresponding base tables row. This is how I have avoided an all amp operation by creating a unique secondary index on the column. For example, if I don't have a secondary index, what happens? There is no hash on this customer column, so all amps to be involved, all amps has to set their portion of the data, and this particular amp only can return the value which is matched with the condition. But to avoid that, okay, what I did, I have created a secondary index, so automatically a subtable is being created and stored in the pump space of the table, okay, permanent space, and then whenever I use it, okay, first it is hashed and it identified the subtables row, and from this it can pick up the base table row ID and can go to that amp and can pick up the actual data, base tables data. So there are only two amps involved. One is to retrieve the subtable row and the other is to retrieve the base table row. This is what happened when you create a secondary index and when you use the secondary index in the where clause. It always causes a 2 amp operation. Now let us see what happens if I create a non-unique secondary index. See, this is the non-unique secondary index example. We'll consider the same table here, the same customer table which has 3 columns: customer number, customer name, and phone number, and where phone number is the non-unique primary index and distributed based on the phone number. And now I have observed customer name is being used more in the report queries. So I wanted to optimize it to avoid the all amp operations many times. So what I can do, I can create a secondary index on the name, but names could be duplicated, right? Names are not unique at any time. So it should be a non-unique secondary index. So I have created a non-unique secondary index. Create index on the name column on the customer table. So when I created the non-unique secondary index, what happens? Automatically a subtable is being created with the same 3 columns: the row ID of the secondary index values, the secondary index value itself, and the corresponding base tables row IDs, the base rows row IDs. Okay, I have used my non-unique secondary index in the where clause of the query. Select star from customer where name is equal to Adams. What happens when I use Adams in the where clause? It is hashed because parsing engine know there exists a non-unique secondary index on this column, so it has to be hashed before you use it. So it is hashed and it will find out the hash value, and by seeing this hash value through hash map it will look up and it will identify in which amps these values exist. So it will try and pick up all those rows which are existing in Adams, and from here we will find out the base tables row IDs. Because it is a non-unique secondary index, there are multiple Adams, right? Because duplication is allowed based on the name column, so it is duplicated across multiple amps and it considered those base tables row IDs, and from here it has picked up the actual base table rows. So how many amps are accessed here? In this scenario of Adams where it is duplicated across 2 amps, 2 amps are accessed here and the same amps are accessed here to pick up the base table rows, isn't it? So I can say multiple amp operation, okay, more than 1 amp, more than 2 amps, that is almost a 4 amp operation, but it is the same amp 2 times. That's where it gives you a multi-amp operation. For example, if this Adams is being duplicated more and it has its presence in all the amps, for example, here also I have one Adam and here also I have one Adam, for example, then what happens? all the amps are accessed here, and then again the same amps to be accessed here to pick up the base table rows. So almost all amps I am accessing 2 times. So at that scenarios where the degree of duplication is very much high, the parsing engine will determine, let me go with a all amp operation instead of this non-unique secondary index. So the optimizer have that intelligence to choose either a all amp operation or a non-unique secondary index subtable to access the data based on the work efforts it required to get the data finally. Finally, the result is same, right? But it will see how many amps I have to access, how many times, and then it will determine what is the optimized path of retrieve the data. So it may go with a all amp operation if the degree of duplication of such a particular column is very much high, and if it is very less, then it will identify the non-unique secondary index to access the data with a multi-amp operation. This is what happened when you create a non-unique secondary index and when you try to use a non-unique secondary index. So here I have a question. Do you find any difference in the subtable distribution in case of a unique secondary index and in case of a non-unique secondary index? Do you find any difference in the data distribution or the subtable? Anyone? How the rows are distributed in case of a unique secondary index? It is based on the row ID of the secondary index values, right? But here, how the rows are distributed in case of a non-unique secondary index? You observe, it is not based on the secondary index values row ID. It is based on the corresponding base tables row ID itself. Only the row hash values are generated, but the data distribution and the sorting of the rows are done by, okay, not sorting, but the data distribution is done by the corresponding primary rows, that is base table rows row ID. That's where the subtable row and the corresponding base table row would exist on the same AMP always. So here these 2 rows of the subtable and the corresponding base table rows exist on the same AMP. Why? Because here in case of a non-unique secondary index, the subtable is distributed based on the primary index row ID. But in case of a unique secondary index, the distribution is based on the secondary index row ID. That's where the row of a base table is in different AMP and the corresponding base row could exist in different AMP. Okay, so this is the base difference between the subtable distributions. In case of a unique secondary index, the distribution is based on the secondary index row ID, and in case of a non-unique secondary index, the distribution of the subtable is based on the primary index row ID. Okay. I have given the notes here how the unique secondary index subtable is distributed and how a NUSA subtable is distributed. So you can just go through it. So this is the explanation. Okay. The base difference of a unique secondary index, non-unique secondary index subtable is, in the unique secondary index, the rows are distributed based on the second index row ID. In case of a non-unique second index, the subtable is distributed based on the primary index row ID. That's where it ensures the subtable row and the corresponding base table row exist on the same AMP. So at least we will have a local AMP operation to access the subtable row and the corresponding base table row, because it is expected it could be on more AMPs, but still it is a local operation on a single AMP to get the base table row ID, to get the subtable row ID and the corresponding base table row ID. Okay. Any questions? No? Yeah, Ritu.
Manohar, can you please explain this non-unique secondary index axis once again?
Non-unique secondary
I
index.
mean, because of this row ID is being distributed. I didn't get that now.
Okay.
Difference.
Okay. Yeah, Purnima. Go ahead, please.
Manohar,
Yeah.
what is this table ID?
Table ID. Come to that. Okay. This is also one component of the hash algorithm, which identify each table uniquely with the help of the table ID. Okay. So on AMP, you will have different tables stored, right? So to identify each and every table, it generates a table ID also. So along with this row ID, so within the table it uses the row ID, but across the AMP, on the AMP, different tables are stored. So to identify each and every table, it uses the table ID. Okay.
Okay, to identify each table, it will use a table ID.
Yeah, on the AMP, because
How,
you know, on AMP it will have multiple tables, the portion of each table. Right?
yeah.
So to identify that, it will use the table ID.
So how it's generated this table ID based on what values?
The same story. The hash values, okay, the parsing engine, the hash algorithm will generate the table IDs.
Okay.
Yeah. Okay. So let me explain non-unique secondary index. Okay, once again. So non-unique secondary index, when you create it with the syntax, it generates a subtable with 3 columns: the secondary index row ID, the secondary index value, and the corresponding base tables row ID. Okay. And the distribution of this non-unique secondary index is based on the corresponding primary index row ID. Okay. The data distribution of the subtable is done based on the row ID of the secondary index, row ID of the corresponding base table's primary index. That's where it will ensure the subtable row and the corresponding base table row would exist on the same AMP. So these are same AMPs. See, AMP1 and AMP1. To distinguish different table, we are showing it as different, but this AMP is same, this AMP is same. So you can assume it as, okay, this particular portion is stored here at the bottom of this particular AMP. This is the assumption. Okay. This portion of this subtable is stored just bottom of this particular table's portion. And it is similar for all the AMPs. The base table and the subtable. The base table and the subtable on each AMP is stored, and when it is distributing the secondary index subtable rows, it ensures the subtable row and the base table row exist on the same AMP. That's where we say the distribution of the non-unique secondary index subtable is based on the primary index row ID. And when you use this second index in your retrieval queries, it will be hashed and it will pick up the subtable rows first, okay, based on this subtable hash values. The second index hash values, it will pick up the subtable row first, and from here it will find out the corresponding base tables row ID, and based on this it will identify in which position on the same AMP the base table rows exist and will retrieve the data. So here in this example of Adams, it is a 4 AMP operation, but you can consider it as 2 AMP operation because it is a local to each AMP. But if Adams exists here also, then what happens? One more AMP is accessed here. If Adams exists in the 4th AMP also, then it is an all AMP operation and each AMP is accessed 2 times. So better than that, we will go with a all AMP operation. Clear?
Thank you.
Okay. So just go through the notes here because it is a bit tricky. I just mentioned how these subtables are distributed here. Just go through those. And this is a snapshot of showing you the differences between the primary and secondary indexes. Yeah. So you can also go through this. There is no much complex. Just, few of the highlights I will just focus on. Mandatory or not, that means required. The primary index is mandatory. up to Teradata 12. From Teradata 13 onwards, yes, with the keyword no primary index, you can have a table without a primary index. That's where there is a star and the condition is explained. But secondary index, no, it is not mandatory. As per the usage patterns, you may prefer to have a second index or not. A table can be without any second index defined on it. How many primary indexes we have on a table? Only and one, always. You cannot have multiple primary indexes. The table will have only one primary index, whether it could be a unique or non-unique, but it should be always one. Second index, you may have 0 second indexes, or you may have up to 32 secondary indexes. What is the composite column number? In both the cases it is 64. So you can create each index with a composition of 64 columns. Both could be unique or non-unique. Right? And row distribution is affected by only and only the primary index always. No other index will impact the data distribution. So second index does not impact the data distribution. Primary index, can it be created and dropped dynamically? No. At the time of table creation only you can create a primary index, and you cannot drop or alter the existing table's primary index. So there is no modifications allowed on the, not on the values, on the column we are saying. In the structure, in the structure of the table, you cannot create or drop or alter the primary index dynamically, but the values can be updatable, right? And at this time of second index, you can create it or drop it at any time whenever you want. Whenever you feel this is being used, you can create it. Whenever you feel that it is not being used anymore, you can drop it. Because what happens if you drop it? The subtable is dropped. When you create it, the subtable is created. So it doesn't impact the actual table at all. It impacts the subtable which is being created. And primary index, yes, improves the access. Second index is also to improve the access. Right? Multiple data types. Yes, while creating the indexes, you may use a combination of different data types as composite. Separate physical structure. It is not required in case of a primary index, but at the time of second index, yes, a separate subtable is being created as a separate structure which holds some memory, right? Which occupies some memory. And it is a processing overhead also. Why? It is a processing overhead because whenever you are inserting the data into the base table, the corresponding subtable is also should be populated with the corresponding subtable rows. Whenever you are updating the second index values here on the base table, the corresponding distribution should happen there in the subtable again, the redistributions as per the updated values. And whenever you are deleting the rows from the base table, the corresponding rows should be deleted from the subtable also. So whatever operation you perform on the data on the base tables, the corresponding operations to be take place on these subtables. So it is a maintenance overhead. For example, I have 10 secondary indexes on a table. Whenever I insert data, all the 10 subtables should be populated. Is it an overhead or not? And they all occupy some space. So in terms of space also, they occupy the cost. Yeah. They're costing because they occupied in the memory and processing overhead. Okay, so based on these two, we have to identify if this particular secondary index is giving a feasible profit or not. It is not that I'm using this particular column in one of my queries, so I am creating a second index to optimize this query. It is not only the factor get to see this column is being used in your query one time, that's where you are creating the second index. No. When you are creating the secondary index, you have to keep in mind that it is occupying space and the overheads, the maintenance overheads. So you have to identify, if I create a second index on this column, how many times this column is being used to retrieve this data and how many users are using it per day. These two calculations also we have to do such a way the memory and the management overhead, whatever we are having on the tables, will be getting a break even through to get you in the profits. Okay, so for example, I have identified a particular column as the second index. I have created it, and this is being used only once per a month per a single user. So shall I go and create a second index for it? No, right? Because the memory used, the overhead what I have, every day the table has to be populated. So every day the second index of table is populated again based on the base table modifications. But this column is being used only once per a month per a single user. Is it going to get any benefit for me? It's okay, all amp operation per a month per a single user, right? So you don't create a second index for that. But you identified 100 users are using the same column in the where clauses 10 times per day. Then yes, you can go ahead and create a secondary index on the particular table. So you have to show that feasibility profit. Okay, so these many number of users on an average, they are using this particular table based on this column. Okay, and if we don't have second index, it is going for all amp operation with this much of CPU. And if I create a secondary index, okay, these many times, these many number of CPUs are saved. Okay, so with that calculation, you can go and create the secondary index. Okay. And it can be an ordered by value. No, primary index cannot be an order by value. But yes, at the time of the non-unique second index, you can instruct the second index to be ordered by the values. So let us go back here. What is this ordered by value? In case of a non-unique second index, okay, the distribution is based on the row ID of the primary index, right? And the arrangement within the amp is based on the row ID of the secondary index values. I mean second index hash values. That is row ID. Okay. So that distribution is based on the primary index row ID, but within the amp, the rows are sorted based on the secondary index row ID. But you can instruct the secondary index distribution. Okay, the sorting order should be based on the hash value, I mean the secondary index values. That is on name itself. Okay, you can add one more keyword, order by value, while creation of the index, so that the sorting order of the subtable rows would happen based on the secondary index values, not the row IDs. What is the advantage if I create a order by value secondary index? Okay, when you have some range queries in between, for example, it is a date kind of thing or some number, if you are using in between conditions, then it is easy, okay, to give you the result set with the range conditions. Okay, that is the advantage when you create a second index with an order by value. By default, it is arranged within the amp based on the row IDs of the secondary index values, but you can instruct it so that the sorting order would happen based on the secondary index values itself. The advantage is the range queries will be performed a bit higher performance. And the partitions. The primary index can be partitioned further, but second indexes cannot be partitioned. We'll see what is a partition primary index, what happens if we create a partition primary index, and what are the advantages and when you have to propose it. We'll see in the next session. The partition primary index, PPI. These are the snapshot of differences between the secondary index and the primary index. And this is again one more snapshot just to give you more clarity about the keys and indexes, whatever we have gone so far. You just go through it and let me know if you have any questions. Okay, the primary key, foreign key, primary index and secondary index. Just go through these differences. You'll get more clarity against keys and indexes, what we are going to use in Teradata. And here this snapshot gives you the possible data types what you can use in Teradata. Okay, the date data type, which is of length 4 bytes and which is in default with this format. Year along with century, there is 4 Ys, 2 Ms to represent month, 2 Ds to represent date. Okay. If you want the time, there are two types: time with zone or without zone. Okay. Without zone, it is of 6 bytes, okay, hours, minutes, seconds, and with zone, it takes 8 bytes and it appends the zone also here. Zone means the EST, CST, PST, IST, the time zone. Also can add in the time with zone or without zone. And then the timestamp. Timestamp is the date along with the time. Again, as we are including time here, there are two types: with zone and without zone. 10 bytes without zone, with zone 12 bytes, and this is the format. Year, and then hours, minutes, seconds, and the zone. And the numeric data types. Decimal or numeric, both are same. Decimal or numeric data types, okay, which takes two parameters. N is the total number of digits and M is out of N how many digits to be considered as precision. For example, if I give decimal of 5,2, then what it represents? The total digits should be 5 and out of 5 the 2 digits should be precision. So in the integral part it will have only 3 digits and in the precision part it will have 2 digits. So total there are 5 digits. So that means the decimal of 5,2. Okay, so whenever you represent a decimal or numeric, it could be 2 bytes, 4 bytes, 8 bytes or 16 bytes based on the values what you are supposed to store and the size what you give. Okay. So this is the upgradation happened from V2R 6.2 where it can use 38 digits in total. So you can give 38,2 or 38,5 if you want to give more precision values to see. And then the byte int, we all know integer, right? Integer here in Teradata it is of 4 bytes, which can hold minimum of this value up to maximum of this value. But if you have a column which holds only up to 100 numbers, then do you require this integer which occupies 4 bytes always? You know this particular column is going to be used only 1 to 100. Why I have to use the 4 bytes integer column here? I can go for a byte integer which occupies only 1 byte and it is capable of holding -128 to +127. Okay, so I am saving 3 bytes for each row. Okay, so this is also one of the analysis when you are creating a table. You have to identify what values this particular column is being stored and you select a proper data type there. Yes, you can give an integer to store 1 to 100 numbers, but is it optimized? No, you have to analyze, and if you have a confirmation that this particular column is not going to have beyond 127, then go and create a byte integer for it so that it will occupy only 1 byte. So you can save 3 bytes for each and every row. Okay, when the rows are billions, then you can significantly identify how much space you can save from it. Similarly, if you have any value which can store maximum of up to 32,767, you can go and use a small integer. The small integer is one more data type which is of 2 bytes only and it can store up to 32,767. So if you have any value which can store any column which has maximum of 10,000 or 20,000 or 30,000, then no need to go for an integer for it. What the data type you require? The small int is enough. Half of the space you can save. So integer and then big integer which is of 8 bytes and it can store -2 power 63 to +2 power 63 -1. This is the value. Okay, so if you want to store very big values in the integer data type, you can use the big int, which is the data type in Teradata. And the float, real, double precision, all are same, which occupies 8 bytes and it is in exponential formats. E power 100 into e power 6, e power 10, e power 15, whatever the precisions you can use. The float, real, double, all are same. Why we have different names for the same type of data? Because of the compatibility with the other RDBMS. Okay, when you are migrating your warehouse from other RDBMS to here, and in that particular RDBMS real is used, then you can, as it is, migrate the definitions here onto Teradata with this. Okay, that's where to give the compatibility with the other RDBMS for the migrations, okay, it has multiple names for the same type of data. Okay, for the compatibility purpose, they have different names here for the same type of data. Yeah, and similarly, we have the byte, var byte, and blob, the binary large objects, okay, which store the binary data. Okay, for example, some pictures, some graphics. Okay, so graphics, we have the graphics data types. For characters, we have character varchar and long varchar, and for binary data, you can have the bytes, var bytes, and blobs. Based on the size of that particular column, you can declare a byte which allocates the fixed memory. Okay, and if it is a var byte, it's a variable length number of bytes. It won't allocate that much of space fixed, but based on usage, it will be increased that much. Similar as char and varchar. How we have a char and varchar? What's the difference? Char is a fixed data type, varchar is a variable data type. Similarly, we have byte and var byte, and it is the binary large objects which can store up to 2 GB of data in a single column of the table. Similarly, the graphics, var graphics, long var graphics, and a character long object. If there are pictures, along with the profile, if you want to store any picture, the employee picture, then you can store that pictures also in the graphics format. And if you want to save the whole resume, you can go for a character long object which can store 2 GB of data again in a single column. Character long object. These are different kinds of data types what you can use in Teradata. So we'll see tomorrow the partition primary index, what happens, how to create and all. Yeah. Any questions? No? Yeah, Purnima.
I have a question. Manohar?
Mm-hmm.
I just wanted to know what is the difference between varchar and long varchar?
Long varchar is varchar of 64,000. You no need to mention varchar of 64,000. Instead of varchar of 64,000, you can mention long varchar.
Otherwise, there is no difference.
Yeah, there is no difference. Yeah.
So, like if I say long, okay, it's same as varchar 64,000. Okay, and when we use graphics, var graphics and long?
Yeah, if you have any pictures to be stored, if you are employee data or a customer data, if you want to upload the pictures also, the graphical information also, along with the normal columns like address, telephone, along with this you can upload the photos also in the columns of Teradata tables. So there you will define the column as a graphic. If it is a graphic of some 32,000, it will store up to 32,000 bytes in the graphics. If it's a var graphic, then whatever picture size is, it will occupy that much size as per the var graphics. And if it's a long var graphics, it is similar as var graphic of 32,000.
So like if we have some songs like musical files.
The music and those music and those type of data will go into bytes, the raw data, the binary objects. Graphics is pictures.
and that will go in B lob, right? Binary long object.
If you declare that column as blob, then it will go into binary large objects.
So like music files we can store in B lob, right?
Yeah. Okay.
And I had one more question, which I think you were not able to hear me clearly. That as a developer, when we use this hash functions like hash bucket, hash
I already
AMP,
told that, right? When you are doing the analysis on the data with the data profiling, you use those functions and identify how the hash values are used to help the distribution of the data. Okay, you'll see how the amps will get the data here. So let me show you that slide. This is what you are asking, right?
yeah.
Right? This is slide. So
Yeah,
I spent pretty much good time on this slide to explain for other questions. Okay, you have to hear all other questions and answers also. Then you can minimize the questions. Okay, so what we are doing here, we are using hash row, hash bucket and hash amps, and we'll try to identify how the row distribution across the available amps. There's the 7th amp, how many rows, first amp, how many rows, and we'll identify how evenly the data is distributed, and then you can identify if this particular column combination can be used as your primary index or not. Right? So when do you use this? In the development stage, when you are not sure what should be the primary index, then you will use these functions to identify how the data distribution is. Then you can decide whether to go with this primary index or not.
So you are saying that at development stage we can check with various combinations of
Yes.
columns to see which will give us the best distribution.
Yes. Okay. Okay. Yeah. Yeah, Mohammed. Iqbal, I think. Iqbal? Or Samit?
I have doubt in slide number 35. Can you?
Yeah.
Yeah. In this slide, when select query comes, then like we have secondary index, that is not unique secondary index. Then that Adams, like we gave name is equal to Adams. Then our hash map find hash row, that is 567, but it don't know which amp that 567 exactly stored, because we are not storing on the basis of this hash row hash. So it has to go for all amps, like it should be all amp operation.
To identify the subtable rows, was saying?
Yeah, exactly.
To identify the subtable rows, okay, see, you have the row hash value 567 here. Okay, when the 567 comes, the hash algorithm already distributed the 567 based on the primary index row ID, so it knows in which amp this 567 went while inserting the data.
Okay.
So it can go and pick up those rows from all the amps in which it was stored based on the base table row ID. Because while insertion it has take place, right? So while retrieval also it knows the information from where it can pick up the subtable rows, even though the distribution is not based on the secondary index row IDs.
Okay. Okay, thanks.
No problem. Yeah, Mohammed. Well, we are not able to hear you. If you want, you can type the question here. Iqbal, you can type the question if you want. Okay. So if anyone else has questions, you just raise your hand here Okay, by seeing the raise your hand button. So I will unmute you and you can ask the question. Yeah. Yeah, Nurullah, go ahead please.
Hi Manor, actually first 20 minutes I missed the class. So I enter when you say like a secondary index. So did I miss anything the first 20 minutes?
First 20 minutes, maybe probably first 10 minutes. I just repeated what happened yesterday. So I just started second index maybe after 10 minutes or probably 12 to 15 minutes. And then please don't join late. From tomorrow onwards, please be, because I'm opening 5 minutes before to allow everyone to join in a proper way. So please be ensure you join 5 minutes before.
Sure.
So yeah. Your voice is breaking again. Okay. Yeah, Lina.
Manohar, please explain distribution based on primary index.
Distribution based on primary index.
Unique primary index.
Whatever primary index. Okay,
Sorry,
I'm muting.
Yeah, I have written actually. It's a unique secondary index.
Unique second index. Okay.
Yeah.
Can you mute yourself please? I'm getting more echo.
Yeah.
Oh. Yeah, unique secondary index. Okay, it is pretty simple. What happens at unique second index? A subtable is being created with 3 columns: the row ID of the secondary index values, the second index value itself, and the corresponding base table's row ID is also stored as the third row. And whenever you try to access by using your unique secondary index, okay, it is hashed again while retrieval, and based on the row hash values generated, it will identify in which AMP the rows are being stored. So it can jump to that particular AMP and pick up the subtable row, and from here it will identify what is the corresponding base table's row ID and jump to that particular AMP and pick up the base table row. Yeah, so it always a 2 AMP operation when you use a unique secondary index in your retrieval queries. And how the row distribution happens at USI subtable? The distribution and the sorting order is done based on the secondary index row ID. Okay. Clear? I think.
Okay, thank you, Manohar. Yeah, it's clear.
Okay, so Iqbal has asked a question on char and varchar. So do you want to see the difference between char and varchar, Iqbal? So char is a fixed length data type. If you define a character of 5, even you occupy 5 characters or not, it will allocate you the 5 fixed bytes for the character data type. When you use a varchar of 5, okay, it uses a 2 bytes for a overhead for identifying the variable length, and it will occupy only that particular length what actually data element occupies. For example, we'll take one more example, char of 10. For example, we'll take some more high length data type, character of 150. If I give a character of 150, it will occupy 150 characters of bytes. That means 150 bytes fixed. Even though you store only 2 characters or 150 characters, the 150 characters, the 150 bytes are allocated for this column. But if you use a varchar of 150, if you are using 2 characters or 10 characters, it will occupy only 10 characters of size. That is 10 bytes of size. It won't occupy the whole length of 150. And that's where you have to do the analysis when to use a character. If all the columns are having almost same length, then you will go for a fixed char. If you identify some column may have 10 characters and some columns may have up to 150 characters, then you will go for a varchar. Then whatever data you store, that much of space is used as per the data. Okay. Yeah. So before closing the session, any other questions? Okay, so please go through these slides. Yeah, and those who has to install, please start installing. Yeah. So Iqbal, any other question? Just said okay. Okay, fine. Okay. Thank you. Thank you all. We'll meet tomorrow at the same time to the same link. Okay, we have to go with the partition primary index. Okay, okay. I think Iqbal is asking some other question. Data type, if we create categories, values, y or n value or m or f. Okay. We create a categorical values, just 1 byte for m of 1f. Okay, so there will be no overhead of varchar. Yes. Yes. If you identify it is always m or f, there is only one character. Okay. So here the question is about the columns which are having only one character. Okay, if I have values y or n or m or f to be stored in a particular column, what we use? Okay, we generally use a character of 1 because we know it is going to hold only one character at any particular time. Okay, so we can go with character of 1 so that you can avoid the overhead of the varchar. Okay, so anyway, it is not 1 byte or irrespective of the number of bytes. If you feel that the number of characters what you are going to use consistently across all the rows, then you go for a fixed length character data type. If it is not certain how many number of characters will be inserted in the particular rows, then you will go for a varchar. Okay, and one more implementation technique what you have to remember is, if the column size is less than 10, then go for a character. Okay, if the data size is more than 10, okay, it is also again based on your client's requirement, client's best practice. You have to see the client's best practice document, and they may tell you, some clients may tell you 5 characters to be considered as a fixed character, and more than 5 you consider it as a varchar. Okay, there is a thumb rule. What you remember is, if the character data what you are going to store in this column is less than 5, you go for a fixed length character. If it is more than 5, then you will go for a varchar. With this, okay, with less confusion, you can get a proper type of column to be defined for that column. Okay, let me repeat it. If the column length is less than 5 characters, you go for a fixed length character data type. If the length is more than 5, then you will go for a varchar data type columns. This is a simple thumb rule, okay, which you can use and can optimize the column data. Clear? Okay. Good. Thank you. So I'm closing the session for today.